Here's a couple different solutions for this number 14. One of the things is um, I'm fairly comfortable with the identity that that sine squared theta plus cosine squared theta equals 1. But there's two other Pythagorean identities that I use from time to time, and that is 1 plus the tangent squared theta equals the secant squared theta, and 1 plus the cotangent squared is cosecant squared. Anyway, the thing that I want here is that I see the secant squared theta minus 1, I'm thinking, maybe that's something nice. And in fact it is. If I take the 1 and put it over here, tangent squared theta is secant squared theta minus 1. So that denominator right there is equal to tangent squared theta. Actually tangent squared t, because this is a t here. So you got a secant squared t on the top and a tangent squared t on the bottom. I then write things in terms of sines and cosines. 1 over the secant is reciprocal of the cosine of theta, and the tangent is sine squared theta over cosine squared theta. And then I'm just dividing fractions. So I have the first fraction. I'm going to divide, so I'm going to multiply by the reciprocal. So I've got cosine squared theta over sine squared theta. Right. And then everything's multiplication here now. So I'm multiplying and dividing by cosine squared. They cancel out. I've got 1 over sine squared theta. But we know that the reciprocal of the sine is the cosecant. Right. So cosecant squared theta is what we're looking for. So that's one way of doing it if you recognize this identity. Okay. Now suppose you don't, and a lot of people don't. In fact, myself as a student, I never would have done this because I didn't like secants and tangents. I like sines and cosines better. So let me redo this problem. Let me write it down again here. I'd be more inclined as a student. I would have done this. I'd have gone straight for sines and cosines to start with. So the top is 1 over cosine squared t, and the bottom is that secant squared turns into 1 over cosine squared t as well. And now I just have a big fraction, right? But I don't mind big fractions. In fact, I think a couple of people have pointed this out in the discussions. To simplify this big thing, if you look at your denominators, I got a denominator of cosine squared, I got a denominator of cosine squared. So multiply top and bottom by that denominator, cosine squared t. Right. The thing is, this times that, they cancel out, leaving just a 1 on the top. There's a distributive property that puts it into both of those. The cosine squared t times that thing is just 1, and the cosine squared t times that is just cosine squared t. Right. So in that way, you turn this big fraction into something smaller, and then it's like, okay, now do I recognize this, the 1 minus cosine squared t? Well, now I'm back up looking at, where is it? Up here, 1 plus the sine squared t. So if I bring the cosine squared over to the other side, subtract it over to the other side, I'm going to have that the sine squared theta is 1 minus the cosine squared theta, and that's what I'm looking at here in the denominator. This 1 minus cosine squared t is looking like that, and so this denominator is sine squared t, t, but 1 over sine squared t is cosecant squared t, and there you go. So there's a couple different ways of doing it. I don't care which way you do it. You'll be more familiar with one set of identities than others, and you just use the ones that get you where you need to go.